Hello, this is Diptendu, and I'm going to be presenting the course project for Machine Learning Foundations for Product Managers today. So what we're trying to do here is we're trying to predict the energy output from our system, and the energy output is in the form of an integer number. We have four different features available, which are essentially the different ambient values of the environment, and we're trying to understand how the environment actually impacts the amount of energy produced. So since this is the output is an integer value here, the type of task is going to be a regression task. And for a regression task, I'm going to be choosing the output matrix as mean squared error. So now the first thing I wanted to do is to see which features I would like to choose. And in order for me to choose different features, what I've done is I have plotted the correlation of different features with the output variable. And I think what I see here is all the four features seem pretty highly correlated with the output variable. So based on that, I feel like all these four features could potentially play a role. Obviously, I'll be building different models based on uh, whichever gives me the correct error rate. But based on this particular analysis, it seems like all the features could be potentially relevant to the model. Next, the options for the model. So since this is a regression model, the different algorithms we could use are linear regression, lasso or ridge regression. We can use decision trees. All these could potentially output an integer number. These will be the different options that we could potentially use. Um, Going forward, I've actually used a linear regression using Excel tools. So that's what I'm going to be showing next. So this, as part of the setup, I have taken the data and have split it up into test, validation, and training sets. So training set has around 7,000 data points. Validation set has 1,000, and the test set has 1,500 data points. Over here, I'm comparing two different models. So on the left, I have a linear regression model using all the available features, all the four of them. And on the right, I have a linear regression model using 3 out of 4 features. So on the left, the model shows the different coefficients, starting with the intercept or the constant value. And as you could see, the mean squared error value that I get here is 23.77. On the right side, the linear regression model with 3 features has slightly different coefficient values, and the mean squared error is 23.87. So the mean squared error actually has increased, meaning that the model on the left is more efficient, more performant model. These model comparisons have been done using the same validation set, which I'm using a fixed validation set approach for. So essentially, it shows that the model on the left with all four features is the right model to go forward with. I'm going to be doing linear regression using this particular model. So again, and then finally, after we have chosen the model, I'm doing a model performance here with the test data set, which had around 1,500 values. I have chosen the model, the linear regression model with 4 features based on the validation set results. And as you could see, the performance evaluation here, the mean squared error is 20.99. The mean absolute error is 3.63. And just for the sake of understanding, the 3.63, you could compare it with the average value of PE, which is 454.22. What the mean absolute error 3.63 is showing us is the predicted value would be potentially in that range. I think it will be an error of a maximum of 3.63 out of 454 average value. Now a little bit of interpretation of the model. So we have a high intercept value, meaning that the environment features are playing a role, but they're not contributing as much to predicting the PE value. The intercept itself is 450, which is pretty close to the average value of PE, meaning that the intercept, the constant value is able to, the PE value is very close to the constant that we're getting out of the model. And then out of the four features, you could see that there are three features which are negatively correlated, which is the temperature, the V, which is exhaust vacuum, and the RH, which is the relative humidity. And there is one value which is the AP, which stands for ambient pressure. That's the only positively correlated, meaning that uh, the PE value is going to go up with lower temperature, lower exhaust vacuum, and lower relative humidity, and it's going to go up with as we increase the ambient pressure. So that's all from my presentation. Thank you so much for listening to me.